So let's look at the types of capsules. So there are two types of capsules. We have the hard gelatin capsules and then the soft gelatin capsules. The only difference is that the hard gelatin capsules, first of all, it contains solid medicaments, while the soft gelatin capsule, it contains either semi-solid or liquid medicaments or products. And then also, we're saying the hard gelatin capsule, it contains two body pieces. So it has the body part, which is larger, which is also the one which is used for filling the drug. And then it also has a cap, which is just like a closure. And then what is similar about them is that they all have the coating, or the enclosing shell is made of gelatin. So I'm saying hard gelatin capsules, these are solid dosage forms, okay, in which enclose the drug, and this drug is going to be solid in nature. So it can either be in form of granules, pellets, or in powder form. And then apart from that, it's also important to note how are these capsules then filled. So capsule filling, or how do we get the drug, the tablets, how do we get, let's say, your granules, your pellets, or the powder into the body? So capsule filling principles, okay? So capsule filling principles has been explained by 4 principles. So the first one is the Auger principle, and then we have the vibratory principle, the piston principle, and then also the vacuum principles. So these are just principles that explain how these capsules are filled. So let's look at the Auger principle. So in the Auger principles, this one, it's a semi-automatic process. Filling is based on the volume of the powder, and also for this principle to be very successful, your powder should have very good flow properties. Okay, and then so we're saying that during the Auger fill principle, or when we're using this process, it has what we call the rectifying unit. Okay, so it has what we call the rectifying unit. So in the rectifying unit, that is where the empty shells are introduced. So the empty shells, we're saying the the body shell, then also the cap shells. So the cap shells and the body shells, or the empty shells, they are introduced into the rectifying unit. Now the function of the rectifying unit is to position, or is to rectify both the body and the cap in a position which is going to enable filling of the body, then also to enable joining or capping using the cap after the filling is done. So the rectifying unit, it rectifies, and then it descends the capsules in such a way that the caps are turned upwards, and then the bodies, they are turned downwards. And then after that, so from the rectifying unit, they are placed one by one into the filling ring, which is maintained on a rotating mode. So you're going to have a rectifying unit. From the rectifying unit, the unit transfers them to a filling ring. Okay, so they are placed one by one on the filling ring. So what is placed here? Here you have the body. So they are placed one by one on the filling ring. And then now that okay, so you're going to have the lower filling ring and then the upper filling ring. So the lower filling ring, that is where the body is going to be placed from the rectifying unit. So the lower ring, it rotates at a suitable speed, which enhances filling of the body. So in such a manner that the hopper, so the hopper is just like okay, so you see when you go to vibratory, so the hopper, so this is the machine or the equipment which contains the powder. So here the hopper is placed, the hopper which has the drug or the powder or the pellets, whichever one you're filling in. So it is placed, or it is held above the filling ring, okay, such that now after your body has been placed in the filling ring, which is now under the hopper, the auger now is going to drive the drug, or which is in powder or your pellets or granules. So it's going to drive your drug into the body, and then after that the cap is going to be placed over. So here it's the auger which it is the one which enables the movement of your drug from the hopper into the body of the capsule. Where are they coming from? They're coming from the rectifying unit. So from the rectifying unit, where there are empty shells, they're directed to the feeding ring. This feeding ring is on a rotating mode. So why the rotating mode? Because it's the one which it enables it facilitates feeding of the body capsules. So it has to rotate at a suitable speed. And then as it continues to rotate, the hopper now, which is placed over the ring, okay, by the help of the auger, it drives the drug into the body capsule. And then afterwards, so this is like semi-automatic, so the capsule are placed over the bodies. So normally that's what happens. And then the other one is the vibratory principle. So here we're saying we're applying vibration. We are applying vibration to enable filling of the capsules. So in the vibratory principle, first of all, you have the hopper. So let's say this is the V shape, this is the hopper. So here the feed is placed in the hopper. So let's say you had the feed right here. Okay, so the feed is placed in the hopper, and then the capsule bodies are placed under it. So like somewhere here, you're going to have the capsule bodies, and then this is your feed. Okay, so this is, let's say, the hopper. Okay, so the feed is going to be placed in the hopper, and the capsule bodies are placed. So this is the capsule bodies. So the capsule bodies, they are placed under this hopper. And then now you're going to introduce a resin. Okay, so a perforated resin plate, you're going to introduce a plate which is called a resin plate, and then it's perforated. Okay, so a perforated resin plate, it is placed in the feed, okay, or inside in the hopper, and then it's made in such a way that it can vibrate. Okay, so as it undergoes vibration, or as the resin plate vibrates, the powder flows freely via the pores into the bodies. So what happens is that inside, so you're going to put your powder like both. So the hopper is fitted with a resin plate which is perforated, okay, and then so your powder is going to be on top of the resin plate. And then this resin plate is made in such a way that it can vibrate. So as it vibrates, okay, so it facilitates the movement of your powder through these pores, then into these capsules. So these are predetermined volumes that enter the bodies. Okay, and then I'm saying that your powder, it should have it's not really that it should have good flow properties compared to this one, because here you have vibrations that actually assist the flow, but still your powder should still have good flow properties. So here that's it. And then after they have been filled, the caps are replaced. So it's just you have a hopper, and then the capsules are filled using the vibration principles, using the resin plates. So for example, one of the machines that uses this principle is the Osaka machine. Okay, so the next one is the piston. The next one is the piston principle, or the piston tamp. So what happens here, it involves the use of a piston. Now the only thing here is that when it comes to the piston principle, here there's alteration of the powder form, okay, or there's alteration in the powder shape. So the powder here is converted into a slag. Okay, so this piston, what it does, it's going to compress the powder. So some certain pressure is applied using the piston or piston tamps, and then they compress the powder into slugs, okay, or into tablets. Now it is these slugs then that are transferred into the empty bodies. And also we're saying that the slide pressure which is applied is between 52 to 100. Then after that, the bodies are ejected from the machine, and then the capsules are placed over. So that's it. So the most important thing to note about the piston terms or the piston principle is that it alters the shape of the powder. It's not the powder which is filled into the capsules on its own. So first, the piston term, it has to compress the powder into slugs or into tablets or into compact masses. Then it's these now compact masses that are transferred into the empty bodies. Then after that, they're ejected from the machine, and then the caps are placed over. So for example, dosager machines and dosing disc machines, they also use this principle. And then we also have the vacuum principle. So on the vacuum principle, we're simply just saying again, here we use vacuum to vacuum. The application of vacuum here facilitates the filling of the capsules. So what happens here, you're going to have the vacuum principle, or the vacuum method. It consists of an open-ended cylinder. Okay, so like what I was trying to put here. So it consists of an open-ended cylinder. So we start from this one, forget about the first one. So it consists of an open-ended cylinder, such that the upper end is fitted with a piston. So it also uses a piston. So it means there's pressure which is going to be applied. So it consists of an open-ended cylinder. The upper end consists of a piston. Okay, and then the open end is placed in the bulb powder. So as you can see here, you have one end where you have this piston, and then the open end, the other open end, okay, is placed in the drag. And then what happens is that then after the open end is placed in the drag, vacuum is now applied. So when vacuum is applied, the piston moves upwards. So it's just like a syringe. Okay, so it's just like a syringe, only now you're using your own hands. So it's like if we used a syringe here. Okay, so we have a plunge. We have a plunge from the syringe. So first you're going to put your syringe here, and then you're going to draw your syringe. You're going to move your barrel. You're going to move your barrel upwards, and then as you move it upwards, it means it's going to suck out, like the same way you would withdraw a solution from using a syringe. So it's the same principle here. Only now you're using you're using a piston and a vacuum instead of pressure. So here, after vacuum is applied, so it forces this piston to suck out a predetermined amount of the powder or a dose. And then after that, the piston now is pressed. After removal of the vacuum, the piston now is pressed downwards, and as it is pressed downwards, whatever amount had been sucked of the powder is now introduced into the body, and then the cap is placed. So the best way to remember this is to always think of the syringe, like how you use the syringe to withdraw a liquid, a predetermined amount of the liquid. Then after that, you transfer the liquid to wherever you want it to go. So this is the principle which is applied here. Okay, and then we're saying that how hard gelatin capsules are filled. So for the other one that has remained, mostly the principles are the same. So let's look at the filling of hard gelatin capsules. How are hard gelatin capsules filled? What is the general process? So I'm saying, first of all, there's rectification of the empty capsules, okay? Such that, so under rectification, we're saying you're going to have now the caps and the bodies. They all have to be in a certain position so that they facilitate filling and also adjoining. So first of all, there's rectification of the empty capsules, and then there's so they can be rectified, and then there's separation of the caps and the bodies. So rectification, you just position it because it's coming after joining from manufacturing. It's closed. Okay, now when they're taken to the rectifying unit, it rectifies them in such a way that the body is going to be facing downwards and the cap, let's say, upwards when it comes like to the first method. So the first one is rectification. So they're all in positions which facilitate either filling or joining or closing. Then the separation of the body and the caps, and then now there's filling of the capsule, and then there's replacing of the cap on the body, and then ejection of the filled capsule. So in general, this is what happens regardless of the process. So types of feeding, so these are manual feeding or punch methods. Manual feeding, so this one it involves more of you have to do more work. There's less of the machine doing work here. So there's manual feeding, which is also called punch methods, and then there's also a hand feeding or semi-automatic. Here you can use a semi-automatic cup device, and then number 3 there's automatic feeding machines. So here you just introduce the capsules. The machine is automated in such a way that it is going to rectify, it will separate, it will fill, it will close, it's going to eject. Then after that, so the machine is automated to do everything. Okay, so what happens here is that for the automatic machines, for example, they can actually like fill and eject or completely just fill about 100,000 capsules per hour. So these they are better than using these. These are more effective, I think, when you're doing just a low. These are good for massive production. These you can use them maybe are just for a few patients or just for learning purposes in the lab. Then you can use especially this one, especially the manual or the hand method, especially the manual. This one would be good. So let's look at the feeding machines. Okay, what are some of the feeding machines that have been used? Capsule feeding machines. So we have, for example, the LEDV. Then we have the pharmatic machines. We have the Hofingers and Kang. We have the Park Davis, the Osaka, the Makofa, SARS, and then we also have the Zanasi Nigris. Now these ones, they are all used to fill capsules, but then they may use different principles. The only thing is that they differ in design and output. Otherwise, they will all be used to fill hard gelatin capsules. So let's look at the punch method, which is also called manual filling. So for this one, this is the one which is mostly used in the lab, okay, by students. So what happens is that you're going to place your powder first of all. So a powder, first of all, is placed on a clean sheet or on a paper. Okay, so first of all, a powder here, you're going to place a powder or the pellets of whichever powder you're using. So you're going to place it first of all on a sheet of paper. And then you make sure that it's the height is like the height of your powder. It should be more than or about a quarter, okay, so that it can facilitate filling, or almost about a quarter or 1/3 of the body, the size of the body capsule, so that it can facilitate filling. And then after that, you're going to hold your capsule, okay. So you're going to hold your capsule over the powder, and then after that, you're going to dip it into the powder. Then so it means as you dip it inside your powder, some powder is going to enter. So you continue. So while you're holding it downwards, so you can just like so you can move it or hold it against the a plain sheet. Okay, so you continue doing that, okay, so that it facilitates filling. Then after it's filled up, then you can place over the cup. So mostly what happens here for the punch method or the manual, you're using it in the lab. So you're going to place your powder on a clean paper, okay, and then after that, so you place your powder using a spatula. Then you should make sure that the height or the depth of your powder is almost about a quarter or 1/3 of the body capsule, so that it facilitates filling. And then you're just going to be using your hand, okay, you place it down, then you're going to move it against this, again you continue placing so that it facilitates filling. When it's fully filled, when you're satisfied, okay, then you can place now the cap over, and you are done. So this one mostly it's not used for mass production. Okay, And then the last part is the locking and sealing of the capsules. The locking and sealing of the capsules. Okay, so now after the capsules have been filled, okay, what happens? So locking and sealing of capsules. So there's what we call these are not in order. This is not saying after one then you do two. So these are just like ways in which your capsule can be locked and sealed. Why are we locking? So that maybe during transportation or use they don't just easily separate. So to maintain their stability and to make sure that the cap and the body are not separated, because if they start separating from the joint, then by the time you're giving your patient your capsule would have been empty. So this is just to make sure that it remains closed and stable. So one, you can use banding. Okay, so banding, this is where you place gelatin color bands at the joining point of the cap and the body. So you can use the gelatin color bands. So these bands can also be used to lock the body and the cap at the joining point. Or you can also use the moistening method. So in the moistening method here, the inner surface of the cap, okay, is the inner surface of the cap. It is rubbed, or you introduce a lukewarm gelatin solution, inside the cap, and then before it's placed over the body. So this facilitates the locking and the sealing. And then apart from that, you can also use what we call spot welding. Okay, you can also use spot welding of the joint. So this is the joint of the body and the cap. Okay, so here under spot welding, a ring-like appearance at the sealing point. So spot welding, this is where where after they've been joined, or after the body and the cap they join together, you're going to see a ring-like appearance at the sealing point. So at the point where you are welding them. So here you can use a certain temperature for welding. And then when a ring-like appearance occurs, then the sealing has occurred, or the locking has occurred. Then there's also what we call thermal welding. Okay, so thermal welding here we're saying, first of all, there's wetting or softening of the meeting point or the joining point. Okay, so what happens is that at the point where the cap and the body joins, you wet them. Okay, so why do you wet them? First of all, to reduce the melting point. And then finally, after the melting point has been reduced, they are now sealed, or they are heated at 40 to 45 degrees. So one question, why do we use 40 to 45 degrees temperature? Why is it used for locking and sealing of capsules? Why is it the temperature that is used? You should be able to answer that. Or you can just use the corn snap capsules. Okay, so this one, it's like it's just like an equipment which can facilitate locking and sealing. Okay, so they contain grooves which lock and snap. So they can either lock or they snap the caps and the bodies. Then after that, there's what we call finishing of capsules. So now your capsules, they've been locked and they've been sealed. Okay, now finishing of capsules. Here it's just so here